All right, so today's deep dive um, takes us into the world of quantum computers.
Okay.
Specifically, we're going to be unpacking some fascinating research about how these things might revolutionize how we solve those super complex math problems,
Right.
differential equations.
Yeah.
Now, before you tune out thinking this is all way over your head, trust me, it's not. We're talking about stuff that affects us every single day,
Hmm.
from predicting the weather to maybe even designing life-saving drugs.
Yeah.
So to help us break down this mind-bending research, I've got our expert standing by, ready to dive in.
Absolutely. Let's start by giving a little context here. Differential equations, they're kind of a big deal. We're talking about the language that describes how things change. Over time or in different conditions, think about something like, oh, I don't know, predicting the weather. Temperature, wind speed, pressure, all those things are constantly changing and interacting, right?
Right.
Differential equations are what let us model that and try to figure out what's going to happen next.
Okay, so they're everywhere, these equations, but you're saying they're not exactly a walk in the park to solve.
Precisely. They can get insanely complicated, especially when you're dealing with a lot of different factors all at once. And our good old-fashioned computers, they tend to hit a wall. They just don't have the horsepower to find solutions efficiently, especially for the really complex stuff.
So where do quantum computers fit into all of this? Is this where things start to get all sci-fi on us?
Well, yes and no. It's definitely cutting edge, but it's very real science. Instead of those zeros and ones that regular computers use, quantum computers tap into the really weird but really powerful world of quantum mechanics.
Okay, I have to admit, this whole quantum mechanics thing, terms like superposition and tunneling, it's blowing my mind a little. It's like we've stepped into Star Trek. Can you break this down for me like I'm five? What makes these computers so special?
Imagine, if you will, that you have a regular computer trying to find the lowest point in a huge sprawling valley. It's going to take its sweet time going up and down every single hill and dip, right?
Right.
Now, a quantum computer, on the other hand, it's like it has the superpower where it can sort of tunnel through those hills, it can explore all the possibilities simultaneously, and zero in on that absolute lowest point much, much faster.
Okay, that's a pretty awesome visual. So it's not just about speed, it's about this whole different way of approaching a problem.
Exactly. And this is where it gets even cooler. This research paper you sent in, it focuses on a specific type of quantum computing called quantum annealing, which is perfect for solving these really tough optimization problems like we were just talking about with finding the lowest point in a valley.
Okay, so quantum annealing is like the perfect tool for the job. But how do we actually use it to solve those differential equations we were talking about earlier? Those things are like the language of the universe or something, right? Yeah.
Right, and that's where this new method comes in, something the researchers call Qade. Think of it like this. You got the super powerful quantum annealer, but it only speaks quantum. Qade is like the translator. It takes those complicated differential equations and transforms them into something that quantum annealer can understand and work with.
So it's like they built a bridge between the world of complex math and the world of quantum computers.
A perfect analogy. And the really exciting thing about Qade is that it's incredibly versatile. A lot of previous methods, they only worked for very specific types of differential equations.
So they were kind of limited, like only having one tool in the toolbox.
Exactly. But Qade is different. It doesn't make assumptions about the specific structure of the equation. It's more like a Swiss Army knife of
Yeah.
problem solving. It
Yeah.
can handle a much wider range of problems. Fluid dynamics, financial modeling, you name it.
This is huge.
Yeah.
It's like having a universal translator for complex math problems, which opens up a world of possibility.
Precisely. And to make things even more exciting, the researchers actually developed an open source Python package for Qade.
Wait, so they're just putting this incredibly powerful tool out there for anyone to use?
That's the beauty of open source. It means anyone with the know-how can experiment with this technology, potentially contribute to its development, and come up with even more amazing applications.
So we've gone from these mind-bending concepts of quantum mechanics to a tangible tool that researchers and developers can actually get their hands on. It's incredible how quickly this field is evolving.
Absolutely. And the thing is, this is still early days. What we're seeing now is just a glimpse of what might be possible. To really understand the potential impact, let's look at some of the real-world problems Qade could help us solve.
So real-world problems. Give me an example. What kind of challenges can Qade actually tackle?
Well, let's take something like drug discovery. This is a field where even tiny improvements can have a huge impact, right?
Absolutely. Finding new drugs and therapies is a notoriously long and expensive process.
Exactly. And a lot of it comes down to understanding how different molecules interact at a really, really detailed level. We're talking about simulating the behavior of atoms and molecules, which, as you can imagine, involves some pretty hefty calculations. This is where quantum annealing powered by something like Qade could really shine. Imagine being able to design and test new drugs virtually much faster and more efficiently than we can today.
That would be game-changing. No more trial and error in the lab for years on end.
Well, it's not quite that simple, but you get the idea. Qade could dramatically accelerate the process, potentially leading to breakthroughs in everything from cancer treatment to developing new antibiotics.
Okay, wow. So we've got life-saving drugs. What else? What other fields could benefit from this kind of computational power?
Pick a field, really. We're talking about anything that involves modeling complex systems. Climate change is another great example. Imagine being able to create much more accurate climate models, allowing us to better predict the effects of climate change and develop more effective mitigation strategies.
So it's not just about making things faster, it's about tackling problems that were practically impossible to solve before. This is really starting to feel like we're on the verge of something massive.
And the thing is, we've only scratched the surface. These quantum annealers, they're still relatively small and limited in their capabilities. But if we can already achieve these kinds of results with what we have today, imagine what will be possible in 5, 10, 20 years as the technology continues to advance.
It's almost impossible to wrap your head around. So where does this leave us? What's the takeaway for someone who's just now dipping their toes into the world of quantum computing?
I think the main thing to remember is that this isn't just science fiction anymore. It's happening now. And while we're still in the early stages, the potential is truly staggering. This research into Qade and quantum annealing, it's a powerful reminder that we're living in an age of incredible technological advancement, and the possibilities really are limitless.
It's definitely a lot to process, but in the best way possible. I think it's safe to say we'll be hearing a lot more about quantum computing and Qade in the years to come. Thanks for breaking it all down for us.
My pleasure. It's always exciting to talk about the future of computing.
And there you have it, a deep dive into the world of quantum annealing and the groundbreaking research that could change the way we solve some of the world's most complex problems.